Hello everyone, welcome to Pace Digital. This is Charita Shankar from Pace Hybrid. Today we are going to discuss regarding the chapter functions. So let me give you a quick recap of the formulae involved in that particular chapter, and we will be moving ahead with the problems involved in that, right? So now observe how many number of functions are there altogether, how many number of functions are there from a set A to a set B. Suppose set A has got m elements and set B has got n elements. Then total number of functions are n to the power m. How does that come? Right. So just think about, so each and every element from the set A will have so many options there, right? So n options there. So n options, even for the second one, there are n options. Even for the third one, there are n options. So that for all the m elements, you have n options. So n into n into n into n into n, so on till m times. So that's how you got your n power n. Now, if it is a 1-1 function, see earlier case, you have another element also to be mapped to the same element. You have another element also can be mapped to the same element. Absolutely fine. But when I'm talking about 1-1 function, mapping can't be done that way, right? So one element of A should be mapped to a unique element of B, right? So 1 to 1, that means suppose if I have m elements here. So for the first element, I've got n options. Later, for the second element, one less option is what I'll be having. So I'll be having n minus 1 options. For the third element, I'll be having n minus 2. Go on proceeding that way. You can reduce that n times. So that means your npm. Right? So this is 1-1 functions. Now coming for the many to one functions. If it is not a 1-1 function, obviously it is many to one function. So from the total number of functions n to the power m, you just subtract npm. That's how you get your many to one functions, right? Now coming for a number of onto functions. So how can we get number of onto functions? Easy to remember the formula. Let me tell you, yeah. So suppose if you have m elements here, n elements here and m elements on the set B. So always start with NC naught. Okay. Let me take another color as okay. So that will be your NC naught, NC1, NC2, NC3. Keep writing that way. Right? The first part, I hope that is clear. So NC naught, NC1, NC2, NC3, NC4. Keep writing that way. Now take n to the power. Start with your n to the power m, just like your total number of functions. That is n to the power m and reducing your n minus 1 to the power m. Next, n minus 2 to the power m, n minus 3 to the power m, n minus 4 to the power m. Clear? Until you get your n value equal to your n minus 4, n minus 3, until you get that value equal to 0, you are going to do this, right? So next, take alternate positives and negative signs there. That's it, right? So basically, how can you remember the formula? Number of onto functions. If you have the set B has got n elements, start with NC naught, NC1, NC2, NC3, NC4. Keep writing that way. Next, go with the n to the power m. Next, n minus 1 to the power m, n minus 2 to the power m, n minus 3 to the power m. Keep on writing that way along with positives and negative signs all over. Is that clear? Right. So coming from number of into functions in the sense total number of functions minus onto functions is what you get it. Now if I'm talking about total number of bijections, it is both 1-1 and onto. So it is n factorial ways is what you'll be having. That means you'll be having same number of elements on set A and on set B as well. Clear? Right. Next, whenever needed, we will be discussing regarding the functional values also, functional equations also. Right, that part I'll be looking into later. We will be going ahead with the questions part now. So let us start the questions, level 2 questions. Right, now observe the question number 1 there. So what is given? Yes, A contains 10 elements and the total number of functions that is derived from A to A. See, both of them has got the same number of elements, that is 10 to, so if it is total number of elements, suppose if this is n of A and n of B. So it is n of B whole to the power n of A. Now they said A has got 10 elements and the given function is from A to A. That is 10 to the power 10 only will be your answer there. So option C will be your answer, right? Now going ahead for the second question, whichever questions are very easy, quickly we can go ahead. So f of x is log, just a minute. Now for the question f of x equal to log 1 plus x upon 1 minus x. The question is find f of 2x by 1 plus x square is how much? Right? So wherever you have x, just replace it with 2x by 1 plus x square. So now f of 2x by 1 plus x square is log mod 1 plus 2x upon 1 plus x square by 1 minus 2x upon 1 plus x square. So observe carefully, you'll be having your numerator and denominator. Observe carefully, solve for it and give for the necessary calculations. You will be ending up with 1 plus x the whole square upon 1 minus x the whole square, which means this is same as writing log 1 plus x by 1 minus x whole square. That 2 comes out 2 log so and so, which is 2 times f of x will be your final answer. Right? Now going for the next question, what does that state? F of x is cos step x. So see, observe, this is cos pi square. Oh, this is step pi square x plus cos minus pi square x. Right. Now, step value for pi square. So what exactly is pi square? So pi is 3.71. Yeah, so 3.4. Now, how can you relate that pi square? So it is just taking a square of that, right? Just take the square 0.14 square, that is your 9.86. Now tell me what is step 9.86, which is same as writing 9. And coming for step minus 9.86, that is the second part, this one. So that will be your minus 10, isn't it? Right? So if at all you have step minus 3.5 or something, will we go with minus 4 or not? That's the greatest integer just before that value, right? So now let me go with the question that is, right. So cos, that will be 9x plus cos minus 10x, right? So that minus pi square is minus 10. Understood? So that is minus 10x. So cos minus basically cos 9x plus cos 10x. So just apply your cos c plus cos d form, you will get your answer there, right? Next question number 4, equation satisfies so and so functional values are given to us. Right. Question number 4. F of x equals f of x plus y is f of x plus f of y. Now you are also given f of 1 equal to 7. Question is regarding r equal to 1 to n. F of r is my question, right? So that means, can I just treat it to be, is it same as writing f of 1 plus f of 2 plus so on till f of n, right? Fine, perfect. Now I am just given a function f of x plus y is f of x plus f of y. I am already having f of 1. So f of 1 plus 1. If I take x value and y value both to be equal to 1, so f of 1 plus f of 1, 2 times f of 1 is what I'll be getting, isn't it? So this is f of 1 plus f of 1. That is 2 times f of 1 and f of 1 is 7. So my f of 2 will be 14, right? Now coming for x equal to 2 and y equal to 1, right? So that will be my f of 2 plus f of 1 again. So f of 2 will be my 14 plus f of 1 will be 7. That will be 14 plus 7, that is 21. So similarly, so when you observe f of 1 is 7, f of 2 is 14, f of 3 is 21. Keeping on doing that way, so what do we get here? So basically, f of 1 from here, that is 7 plus 14 plus 21 plus so on till n terms is what we have, isn't it? So on till n terms. So take 7 common. 1 plus 2 plus 3 plus so on till n. So finally, 7 times n of n plus 1 by 2 will be your final answer, right? Now going ahead with the fifth question there. So square root of, my question here is 1 by square root of x plus 2 root 2x minus 4 plus 1 by square root of x minus 2 times root 2x minus 4. They already said x is greater than 2. All right. So when x is greater than 2, obviously, yeah, just a minute. Now, observe here, can I just split it like 2 times x minus 2, right? So, product of these two, I am able to represent this x as sum of the same value. So, this is 1 by under root of this x is replaced like 2 plus x minus 2. Agree with that? That's it. This x I am just replacing with 2 plus x minus 2 in order to get it to that form. Plus 2 root 2 times x minus 2. So what did we infer from this? Does it look like a square plus b square plus 2ab? It might look, but if it has a square, b square plus 2ab, right? So now that question changes to 1 by under root of a plus b, the whole square, wherein whole square and this gets cancelled. I am left with 1 by root 2 plus root x minus 2, right? Now, same way, if we proceed, now what will be the answer for the other part there? That will be 1 by root 2 minus x minus 2 or root x minus 2 minus 2, which is the best option. That is what we need to check based on the given clue there. Clear? So that part we will see now. See, if at all I have a minus b whole square or b minus a whole square are one and the same, right? But if I am including a under root value, suppose root of this and root of this, when the root is breaking there, my value which is coming out from the root should be a positive value only. Is this point clear? So I cannot have it to be a minus b or b minus. I should precisely take it to be only one value, and that too it should be a positive value only. Right, that point? Now talk about x minus 2. See, we just got to know that x minus 2 is greater than 0 from the inputs of the question what they have given, right? So when this is a positive value, and I also have that part, what is that? 2, right? So I have 2 also positive. Now, which is greater from these two? Tell me. 2 is greater or x minus 2 is greater? How do we decide this? So when your question is regarding f of 11, I guess, right? So obviously 11 minus 2, that will be greater than 2, isn't it? So that means consider your root x minus 2 minus root 2. Now a minus b of a plus b, which is a square minus b square, that is root x minus 2 whole square minus root 2 square in your denominator. Root x minus 2 minus root 2 plus root 2 plus root x minus 2, right? So these two gets cancelled. Final answer remains to be 2 root x minus 2 upon x minus 2 minus 2. That is just to substitute f of 11 in the sense x place 11 to be taken there. So 2 times under root 11 minus 2, which is 9 root 9, that is 3 upon 11 minus 4. 11 minus 4, that is 7. Perfect. So 6 upon 7 will be your final answer there, right? Okay. Going ahead for the next question now. Now, yes, finding the domains and ranges, most important type, right? So for which we need to understand few things first. If at all your question, that is your function, is in the denominator, then what to do? Suppose if you have a function in the denominator, that means obviously denominator should not be equal to 0 for the function to exist there, isn't it? So my f of x not to be equal to 0. Is that point here? Now, if I have a root f of x, which means under root value, whatever it is, doesn't matter for me. For me, f of x will always be greater than or equal to 0. So, value under the root should always be positive or it can be equal to 0. Now, if I have 1 by root f of x, what does that mean? That means your f of x, as it is under the root, it can be greater than or equal to 0. But it is in the denominator, so it is just strictly greater than 0 there. Right? Now, if my question is log f of x base g of x, then tell me your argument has got some options, some restrictions, and base has got some restrictions. What are they? So, my argument should always be greater than 0. Base, that is g of x, also should be greater than 0. And if it is greater than 0, does it mean it can be equal to 1? No. So g of x not equal to 1, also the most important condition there. Clear? So that is one thing what you need to know also. If your log a base b equal to x, tell me from here a equal to b to the power x. Agree with that? Right? Now, if my question is in an inequality form, that means if you have log a base b is greater than 1, or log a base b is less than 1, how are we going to relate them? In this, we've got two options. One option, that is when base lies in between 0 to 1 and when base b is greater than 1, right? So whenever you have base is less than 1, inequality will be changed there. But if your base is greater than 1, inequality will not be changed. So just to remember this fact, log a base b equal to x implies a equal to b to the power x. Conversion of log to exponential form. Same is the case with the inequality, what I'm going to do there. Now tell me from here, if base is in between 0 and 1, if it is less than 1, my inequality should be changed, is what I said. So a will be less than b to the power 1. Okay, right? Just a minute. Greater than equal to 0 is what we will consider here. Sorry. Right. So b greater than 0. Yeah. So that is b to the power 0. That is 1. So that will be your a is less than 1. Here, if you go with the a, is when base is greater than 1, it goes with the same inequality. So b is greater than b to the power 0. That is a is greater than 1 there. Clear? Now coming for this case, when log a base b is less than 0, then what? Here also two cases arise when base is in between 0 to 1 and when base is greater than 1. Now in between 0 to 1, in the sense, obviously inequality will be changing there while shifting up that value. So a is greater than b to the power 0 or a is greater than 1. Now coming here, when base is greater than 1, what do we get? A will be same, remaining the same. It will remain the same. A will be less than b to the power 0 or a will be less than 1. Clear with all these four cases, right? So each and every function is what I am discussing. So how are their domains and all? All these domain questions will be solved or cracked using these. That will be enough. Right, now going with the domain question number 6. So you've got log x plus 3 base 2 upon x cube plus 3x plus 2. This is your question domain of that. So here we have two things to understand. Denominator function should not be 0. That is my first case. Case 1, my denominator, that is x square, right? So x square plus 3x plus 2 not to be equal to 0. That is my case 1. And coming for the case 2, my argument of the logarithm should always be greater than 0. That is, x plus 3 should always be greater than 0. From here, x is greater than minus 3. And here, just to split the inequality, 2, the factors are 2 and 1. So basically, that is x plus 2 of x plus 1 not equal to 0. That means x cannot be equal to minus 2 or minus 1 in the set notation. Right. So if it is greater than minus 3, strictly greater than minus 3, which means, is it towards right? And towards right, do you have that minus 2 and minus 1 also coming under that case, which we are not supposed to include? Hence, you are getting the question as minus 3 to infinity, you can go with minus 3 open, infinity open, but subtract your minus 1 and minus 2 values, or remove your minus 1 and minus 2 values from your set there. Clear? That's it. Now the next question, number 7, it's again a domain function with the 3 roots. See, observe carefully, when you have 3 roots, each and every condition to be satisfied there undoubtedly, or else the other might feel bad, isn't it? So each and every condition is what we need to satisfy. So question number 7, case 1, that is under root x minus x square. That is my first part. In this, my first term under root value is always to be greater than or equal to 0. So x minus x square greater than or equal to 0 is my first case to be detected. Right, now tell me, as I am using wavy curve method, my leading coefficient should always be positive. Right? So I change the sign, then x square minus x will be less than or equal to 0. X times x minus 1 less than or equal to 0. That means take the number line representation with the critical points 0 and 1 with a less than or equal to symbol. Hence, I am shading it with the values plus, minus, and plus. As it is less than 0, my question is less than 0. Hence, I have to go with a negative solution there. That is my first case answer. Right. Now, going with my second case there. So, what is that? That is under root of 4 plus x. Okay. Whatever be under the root, that under root value 4 plus x should always be greater than or equal to 0, which means x greater than or equal to minus 4. So that will be another number line what I am drawing towards right, which is greater. Now for the point 3, I have under root 4 minus x. From there, again 4 minus x is greater than or equal to 0 because it is under the root, and my x or minus x greater than or equal to minus 4, which implies x is less than or equal to 4. Right. So my number line representation for that will be x less than or equal to 4. So here you go with 4. X is smaller than that towards left. Now what is my question? It's all about deriving one common solution for all these 3 inputs, right? So all the 3 cases is what I have solved. I am drawing the number line here. Okay, let me draw a number line, right? So that will be, yes, 0, 1, 4. All right. So 0 to 1 is one of the solutions, and x less than or equal to 4 is another solution. Also greater than minus 4. So we also have a minus 4 there. So greater than minus 4 is also the solution. So wherever I have 3 options matching, that will be my solution set, isn't it? So my 3 options are matching in this region only. 1, 2, 3. All my 3 options are matching in the region 0 to 1. Hence 0 to 1 option D will be my final answer. See that you satisfy each and every condition carefully. Right? All their intersection will be my solution. Right, now going for the next question, that is question number 8. Now tell me, 8th question, that's a function of a square root function, which means my first case, whatever be under the root, that value should always be greater than or equal to 0. Perfect. So log x square minus 6x plus 6 is always greater than or equal to 0 is my first condition. And now for the log to sustain, what should be there? See, if the log itself is not there, how can we do the question? So for the log to sustain, your argument should always be greater than 0. And what is my argument? That is x square minus 6x plus 6 is strictly greater than 0 there, right? These are the 2 conditions. This I think I can do it very easily. Yes, let us go with that. So 6x, can you split this number? This is 3 and 2, you cannot get it. So if at all I go with x equal to minus b plus or minus all that. So I am writing minus b plus or minus under root b square minus 4ac upon 2a. So that is 6 plus or minus under root 12 upon 2. That 12 can be split like 4 into 3. 4 can jump out like 2. So cancellation 3 plus or minus root 3. Right. So that will be the value from second case. Perfect. Now for the first case, see, you have some log base 10, let it be, right? So obviously whether it is base e or base 10, it is greater than 0 or greater than 1, which means can I take my argument x square minus 6x plus 6 without any change of the inequality greater than or equal to 10 to the power 0, 1. So x square minus 6x plus 5 greater than or equal to 0. So 5 factors are 2 and 3 with a minus 2 and sorry. Yeah. 5 factors are 5 and 1 with minus 5 and minus 1, that is minus 6. So that is x minus 5 of x minus 1 greater than or equal to 0. Now what will be the condition there? So this will be 5. This will be 1. And now let us talk about 3 point root 3. Root 3 is 1.732. So 3 plus 1.7 will be 4.7 somewhere here, right? So this part I will take it to be 3 plus root 3. Now 3 minus root 3, that is 3 minus 1.7. That will turn out to be 1.3 somewhere here. This will be my 3 minus root 3. Okay. Now I am starting with just a minute. Let me open that. Fine. So I didn't draw the number lines for the given question first, right? So let me complete that case and this case and then complete. Right. So drawing the number line representation, my critical points for the case 1 are 1 and 5 to be shaded because that is strictly greater than or equal to 0, plus minus plus. My solution lies here and there. Now coming here, 3 plus root 3. And 3 minus root 3. So 3 minus root 3, root 3 is 1.732. That will be 3 minus 1.732, 1.3 something. Isn't it? 3 minus root 3. This is 1.3 something. And the 3 plus root 3, that will be 4.3 something. So 3 plus root 3, that will be 4 point something. Now again plus, minus and plus. So as I said, this value is strictly greater than 0, which means they are lying outside that part and this part. Now take a combined equation for all these critical points. What are they? So you have got 1 and 5 there. So this will be, these 2 points are lying inside only. That is your 3 minus root 3 and this will be your 3 plus root 3, right? So start with plus, minus, plus. Oh, no. Draw the number lines, what you have already given there. So 1 towards left and 5 towards its right. And somewhere, right, so 3 minus root 3 towards left and 3 plus root 3 towards right is what we have the option there. Now, which option is perfectly tallying? So basically minus infinity to 1 and 5 to infinity will be tallying. Right. So minus in option D, C, minus infinity to 1 union 5 to infinity will be tallying there for us, right? Perfect. So wherever you have this double mark, that will be a solution. That is minus infinity to 1, close union 3 plus root union 5 comma infinity. Right. Perfect. Yes, now coming for the coming question, like domain of the function f of x equal to cos inverse of something. So remember one thing, for cos inverse or sine inverse, your domain is always minus pi by 2 to sorry, minus 1 to 1, right? So cos inverse something, what is the domain? Your innermost value of this part should always be lying in between minus 1 to 1 only. So minus 1 to 1, you've got your log x by 2. This will be less than or equal to simple, right? So this will be my case 1 and that will be my case 2. So I am writing log x by 2 greater than or equal to minus 1 under case 1 and log x by 2 less than or equal to 1 under my case 2. So obviously x by 2 which is greater than or equal to 10 to the power minus 1, that is x greater than or equal to 2 by 10 which is 1 by 5. Now coming here, x by 2 less than or equal to 10 to the power 1, that is x less than or equal to 20. So x is greater than or equal to 1 by 5 and to 20, right? So do you find the options? Let us check. Oh, we took the base to be 10. I think the question, I didn't write it clearly. They have given the log base 2, which I missed out in my question. Okay. So let us redo the question by taking base 2 there. Base 2 and base 2. So obviously these are the two things what I am going to change now. You please do it again. I did not see the question. The base 2 was not observed carefully. Okay. Right. As the base, I thought base is not given and I took it to be given. Right. Now x by 2 is greater than or equal to 2 to the power minus 1. Ante x greater than or equal to 2 into 2 to the power minus 1. X greater than or equal to 1. Right. Coming here, x by 2 will be less than or equal to, here also, will be less than or equal to 2 to the power 1. Now x less than or equal to 4. So x greater than or equal to 1 and less than or equal to 4. That will be 1 to 4 will be your solution range, right? Now going with the next question number 10. Here also you get the same domain of the function f of x equal to so and so. You've got two things there to be done. So your function has got two terms. So two terms to be matching there. 3 upon 4 minus x square is case 1 and your case 2 is log x to the power 5 minus x cube to the base 2. This is my question. So both these questions, both these terms is what I have to calculate their domains separately and I'll be taking the intersection part. Now as I'm having 4 minus x square in my denominator can never be 0 there. Hence I will take 4 minus x square not equal to 0, which is x square not equal to 4, which is x not equal to plus or minus 4 from this set. Now coming here, my argument should always be greater than 0. So x power 5 minus x cube should always be greater than 0. Taking x cube common, x square minus 1 is always greater than 0. I took x cube common and x square minus 1. So x cube x plus 1 of x minus 1 greater than 0. Now take the critical points careful way. X, that is x cube, that is 0, minus 1 and 1. So this is 0 or let me take, this is minus 1, 0 and 1. So plus, minus, plus and minus because it is x cube only, odd function only, no problem. So my greater than 0 wherever I have, that is my solution range, right? It is strictly greater than 0, not equal to. Now in my question, see, do I get the value plus 4? Yes, my answer has got a plus 4 in my case too, but I'm not supposed to take it. So one common area what I can take is, this is minus 1, 0 and 1. I can take towards right and minus 1 to 0, but it cannot be equal to minus 4. Somewhere here minus 4 and it cannot be equal to minus 1 also. Right? Understood? It can be anything other than this. So all this will be included, but you cannot have a minus 4 and plus 4. Okay. Now what is my solution range? This region wherein I have the double line is my solution. So my x belonging to minus 1 to 0, my first case open, union 1 to 4 union 4 to infinity. All right. Mm, which question are we talking regarding? Oh, it's 2, it's 2, it's 2, it's 2, it's 2, minus 2 and plus 2. Very sorry, very sorry, very sorry. 2 to infinity. Okay, right. So here you go with your answer. Minus 1 to 0, 1 to 2, union 2 to infinity. Yes, infinite. That option D will be your answer there, right? So x square not equal to 2 there, right? So carefully go ahead with the next question. Please do not do such errors, right? Um, right, now question number 11. Again, finding the domain of the function so and so. It has got some f of x equals to log x square minus 1 to the base 3 plus x. As I said, your f of x, if at all it is argument, your argument should always be greater than 0 and base should also be greater than 0 and base not at all equal to 1. So these are the three things that should be satisfied. So from this case, that is x minus 1 of x plus 1 greater than 0. That is on your number line minus 1 and 1 critical points plus minus plus there greater than 0 into in the sense towards that side and this side. From here, my x is greater than minus 3. So from minus 3 towards right side. From here, x not equal to 1 minus 3, that is minus 2. You cannot take it clear. So now let me go with, yes, the proper number line there. So that is minus 3, minus 1, 1. And in between somewhere we will have a minus 2 also. We are not supposed to have that. Right. These are my critical points, what I am marking there. So minus 1 towards left and 1 towards right is what I take one solution. And minus 3 towards right is what I got another solution. And x not equal to minus 2 is my another solution. Right. So in the sense, it can take every value but not 2. That is how it is, right? So wherever my equation is, all this region will be my answer. Right. So, but here that is minus 3 to minus 2 open bracket union minus 2 to minus 1 open bracket union 1 to infinity there, right? So that is how I get my solution there, right? So option D again, no, option C there, right? So minus 3 to minus 2, minus 2 to minus 1, union 1 to infinity. This will be your solution range for the question number 11. Right. Now going with the question number 12. Yes. Now what are all the options that I can have here? So my root function, first thing, my square root function should always be greater than or equal to 0. This is also regarding the domain function only. So my square root function should always be greater than or equal to 0. Whatever I have under the root, I should have that 2 sine inverse 2x plus pi by 3 strictly greater than or equal to 0 always is my case 1. And I have sine inverse 2x. As I said, sine inverse some value x always lies between, that x lies between minus 1 to 1. So that will be minus 1 to 1. So this is my case 2, right? So this part I think I can go with minus 1 by 2 less than or equal to x less than or equal to 1 by 2, right? Yes, so now this is 2 sine inverse 2x greater than or equal to minus pi by 3 there, right? So that means your sine inverse 2x greater than or equal to minus pi by 6. Perfect, greater than or equal to sine, that is negative, isn't it? So minus pi by 6 in the sense, can I take sine pi plus something, right? So that also can be done, right? Well, as sine is an increasing function, there is no change in the inequality. Sine inverse transposes there as Right. So 2x is greater than or equal to sine minus pi by 6. Perfect. So that is greater than or equal to minus, what is sine pi by 6? Sine pi by 6, that is sine 30. So that is 1 by 2. So therefore x will be greater than or equal to minus 1 by 4. And here you got your x lying in between that minus 1 by 2 and 1 by 2, right? Now observe here. Together we are going to plot them on the same number line. Similar thing what we have done for the earlier cases. So I am just taking one number line that is minus 1 by 2 and this is plus 1 by 2. Now tell me 1 by 4 is greater or smaller than 1 by 2. Basically 1 by 4 is smaller, right? So 1 by 4 is smaller, but minus 1 by 4 will be greater, right? So minus 1 by 4 is greater than, in the sense here it lies your minus 1 by 4. So x is greater than minus 1 by 4 and the question here lies in between these two. Obviously the common solution is minus 1 by 4 to 1 by 2 taken, yes, this way. So minus 1 by 4 to 1 by 2 will be your answer. That is your option A. Right? So the next coming things are all based on the range questions. So till now we have done questions based on domain. Now coming up with the range. So my question is, what is the range of the whole value? So y equal to 1 by 2 minus sine 3x. See, remember one thing, basically, domain is the x values what we are taking. That means the inputs what we are choosing for our question. Coming for range, range is the output what we are getting for the question. So I know that sine 3x anyhow will be lying in between minus 1 to 1 only. Now my thought for this finding range, see, for domain we have some fixed functions and I explained you in the earlier session also, like for all these functions, what we have, suppose if it is root function, take it greater than or equal to 0. And if it is 1 by under root function, it is just greater than 0. 1 by x function, x not equal to 0 is what we will be considering there, right? So there is some predefined things for finding the domain. But for range, there is no such thing. It is your choice, your take on the question, how we are supposed to kill the question, right? Now I am left with 1 by 2 minus sine 3x. So I know sine 3x range is minus 1 to 1. So from this, I am framing my question from this. How I've got minus sine 3x now. I'm supposed to frame this question in that using this inequality. Now I'm multiplying with a minus, in the sense all the sign will be changed. 1 less than or equal to minus sine 3x. Sorry, it is not less than or equal to. Now, as I said, the sign should be changed there. It should be 1 greater than or equal to minus sine 3x, which is greater than or equal to minus 1. Perfect. Now I want 2 minus so and so, which means adding 2 all over. Adding 2 all over. That is 3 greater than or equal to 2 minus sine 3x greater than or equal to, adding 2 minus 1 plus 2, that is 1 there. Now take the reciprocal. Reciprocal always goes with the sign change, if at all the left and right extremities are of the same sign, right? So now 1 by 3 again less than or equal to 1 by 2 minus sine 3x less than or equal to 1 upon 1. So obviously it is ranging from which number to which number? Your y value is ranging from 1 by 3 to 1 is your question there, right? Now going for the next. Now for the 15th question, finding the range of f of x is a cos something plus d. See, whenever we have a linear form, a cos theta plus b sin theta plus c, what is the range of this function? What is its minimum and maximum? That is c minus under root of a square plus b square, and c plus under root of a square plus b square is the minimum and maximum for the given function. Right now, tell me what is A, B and C for the given question here. So A is A only because A cos something. It can be any function, any theta there, doesn't matter at all. So A is A only. B sine theta, B is not there because sine theta coefficient, sine theta term itself is not there. Hence B is 0 and my constant term is C, which is D. So just to substitute here, C, that is D minus under root of A square and D plus under root of A square. So basically D minus A and D plus A are the minimum and maximum values for this question. Right? So D minus A and D plus A, option D will be your right choice there. Right. Now going with the next question, that is 16th, I guess. Right. What is the range of f of x? This is the 16th one. F of x equal to secant pi by 4 cos square x. Now your x is ranging from minus infinity to infinity. My question is, what is the range of this value is my question. Now tell me, secant of any value always ranges from which value to which value? Or else let me start with the cos square onwards, right? See, I know that cos x starts from minus 1 to 1, right? So when I take squaring on both sides, obviously squaring on all the sides, it will be, I cannot have a negative value there, isn't it? 0 less than or equal to cos square x less than or equal to 1 there. Now I multiply by pi by 4 all over into pi by 4 into pi by 4 into pi by 4. As it's a positive value, my inequality will not be changing there. Right. Now I am left with a pi by 4 cos square x less than or equal to pi by 4. This is what I have. Now for applying the secant for any value, we just have to think about whether secant is an increasing function or a decreasing function. If it is increasing function, happy, no problem at all. We can directly go with the same inequality. But if it is a decreasing function, obviously when your x increases, your y value decreases, then we have to go with a change of the inequality sign. Now you people decide whether secant is increasing function or decreasing function and decide its sign there, right? Perfect. So as it is a direct increasing function there, you can just apply secant for the question. That is secant 0 less than or equal to secant this pi by 4 cos square x less than or equal to secant square pi by 4. Now secant 0, what is it? It's a reciprocal of cos 0, that is 1. Less than or equal to my f of x, less than or equal to secant pi by 4 is reciprocal of cos, that is root 2 1 by root 2, hence it is root 2 square, that is 2. So now my question, oh, it's not secant square, sorry, it is secant. So that will be your root 2 only, right? So my question is ranging from 1 to 2. Yes, option A will be my right choice there, right? So that is another type of the question in range. Now coming for the 17th question there, what is the range of f of x equal to so and so? Right. So whenever you have such questions, this is most important kind, x square plus 3x plus 1 upon x square plus 3x, oh sorry, plus x square plus x plus 1. Now I just equate it to y. For such type of questions, when you have some fractional form of kind, so x square plus 3x plus 1 upon x square plus x plus 1, just equate it to y. Take the cross multiplication to the other side. So x square plus 3x plus 1 equal to your y times x square plus x plus 1. Bring everything on one side, equate it to 0 first, right? That means, see, from a quadratic in terms of x square. So I will be getting x square taken common, that is 1 minus y, plus x taken common, 3 minus y there, plus 1 minus y is what I get, which is equal to 0. Now, as they said, the given, see, x is real. So when x is real, obviously the discriminant should always be greater than or equal to 0. Agree with that? Right? So discriminant, that is b square minus 4ac. That is your 3 minus y whole square, b square, isn't it? Minus 4 times a and c. So b square minus 4ac is strictly greater than or equal to 0. Now you just expand this. After expansion, I'm just writing the answer there. So after simplifying all that expression, so all this calculation to be done, and then I am ending with this inequality, wherein the critical points will be taken as -1 and 5 by 3, plus minus and plus less than 0. Strictly here, that will be my solution. So my x belonging to -1 and 5 by 3 will be the answer there, right? Mm, so yeah, that's it. So that will be your answer there. Understood? Right. So till here is what we have done for this session, and for the upcoming session is what we will be going ahead with the upcoming questions, right? So good luck. Keep doing, keep solving questions.